mutually exclusive events means, yeah, I have an event, event X, the elements, I will define the set X, which is prime numbers between 1 to 10. So 2, 3, 5 and 7. 2, 3, 5 and 7. And thereafter next set Y, 4 multiples between 1 and 10. Okay, between 1 and 10. So 4 and 8. First one is the when I define set A, prime numbers between 0 and 10, 1 and 10, and in second case 4 multiples between 1 and 10. Here you can see there is no any intersection between these two sets. Intersection means there has to be some single or more than one elements has to be common. Now in that case we can write X intersection Y. What would it be? In this case you can see there is no intersection. Here 2, 3, 5, 7, here 4 and 8. In this case, if there is no any intersection between two individual sets, if intersection is 0, okay, rather than using 0 in set notation, we are calling it as null set. Okay, null set. If intersection between two sets is a null set, these are called as mutually exclusive events. Mutually exclusive events. In Venn diagram, when we need to denote this, how to denote? This here is a circle and next circle. There is no any intersection. If there is any intersection, we have to denote a common region which belongs to both of these circles. Since it doesn't have any kind of intersection, we can draw two separate circles, 4 and 8. So this would be the notation. Mutually exclusive means there is no any intersection between two individual sets. To denote that, okay, intersection between two individual sets would be a null set. Null set means nothing, 0, like. So both event cannot occur same time. Okay, both are different. So now let's define the previous formula. What's the previous formula in the context of the elements? When I write number of A union B, that is equals to number of A plus number of B, here X, sorry, I'll write that using X values. So number of X union Y equals to number of X plus number of Y minus number of X intersection Y. Okay, here you can see in the mutually exclusive event X intersection Y. What is this? There is no any intersection. So this would be 0. It will become 0. Null set, no. It will become 0. So no need to indicate this one. So in mutually exclusive event case, we can redefine this formula since it is 0. There is no any intersection. We can write, I'll write this one here. Okay. We can rewrite the formula number of X intersection union Y, that is equals to number of X plus number of Y only, no? Think about it. X union Y means X and Y both together. How many elements are there? In here 4, here 2. Number of X is 4 plus 2. So totally 6. Here also 6. Equalized. This is 0. That's why subtracting 0 or adding 0 doesn't make any change in our equation. No. That's why we omitted this one. So when I write this one in the probability case, probability of X union Y, that is equals to probability of X plus probability of Y. For mutually exclusive events only, these two formulas are acceptable. If I ask why, you should be able to answer to the question. Since both doesn't have any intersection, the intersection case, the number of elements belongs to intersection becomes 0. No? So there is no any changes in this equation while subtracting 0. So that's why we are keeping this simple formula in mutually exclusive even cases.